Welcome to session 3 of Unit 4. So on back titration. In this session, we are going to determine the percentage of calcium oxide in a rock sample. Let's look at the objective for the session. The objective is to determine the percentage of calcium oxide in a rock sample using back titration. And we are looking at this question. The quantity of calcium oxide in a particular rock can be determined by reacting a powdered sample of the rock with excess hydrochloric acid. The quantity of HCl remaining is determined by titration, by back titration with a standard base. A is a 0.1 mol per dm cubed sodium hydroxide. B is a solution obtained by treating 1.5 grams of the powdered rock with 500 cubic centimeters of 0.1 molar HCl. Now, before we proceed, for that matter, the solution, let's see if we can draw something from here. As usual, we have the base. Let's look at the species present. We have sodium hydroxide, which is a base. We have calcium oxide in the rock sample, which is a base, is a basic oxide, and then we have HCl, which is an acid. So we expect two reactions here. The first reaction will be the reaction between the calcium oxide in the rock sample and the hydrochloric acid, and second is the reaction between sodium hydroxide and this same hydrochloric acid. But because the first reaction is between the calcium oxide and this HCl, we will have some of this HCl first of all consumed by the calcium oxide in the rock. Then the excess, or what will be left, would now be available to react with this sodium hydroxide in the titration process. So if we understand this, then we know that we are going to find the excess from the HCl. Then we can now look at that of the portion that was consumed by the rock sample. But looking at this, we cannot start from this part. We can only start from this solution A, where we have the concentration here, and we can interpret this because we will have the volume as well. Knowing this, we are good to go. So A here is an instruction, and the B part is gives us the task or the questions to answer. We are to write equations to show the reactions taking place. We have already said that we have a reaction between calcium oxide and HCl and sodium hydroxide and HCl. This makes our work easier. And we are to find the amount concentration of B in mol per dm cubed and the moles of HCl consumed when the powdered rock sample is dissolved in that 500 cubic centimeters of the 0.1 molar HCl. And then we have to find the calcium oxide in the rock. We have to find the percentage. So we are going to use the sodium hydroxide to find the corresponding moles of the acid, and for that matter, the excess concentration of the acid. We will go and subtract from the initial concentration of the acid to know that was consumed. Then, knowing the concentration that was consumed, we will use it with this volume here to find the moles. Then we can do our mole ratio to enter into the calcium oxide. We are to take the volume of the A used to be 19.50. A is the base. So we start the question answering by writing our equations. We have an equation between the sodium hydroxide and the hydrochloric acid. That gives us salt and water. And then the calcium oxide in the rock sample and the HCl, that also gives us calcium chloride and water. So the C part, we now go to the sodium hydroxide and interpret its concentration. It is 0.1 mol per dm cubed. 1 dm cubed, that is 1000. So what it means is that 1000 cubic centimeters of the sodium hydroxide contains 0.1 moles of the sodium hydroxide. If that is the case, then that average volume that was used, this small volume that was taken out of the 1000 will contain how many moles. So we can say that if 1000 is equal to 0.1, then 19.5 is equal to x. We can cross multiply, make x the subject. We'll get the corresponding moles in the 19.5, and that is 0.00195. Or we can just use our relation N is equal to C times V. That is, amount is equal to concentration times volume. The concentration is the 0.1 mole per dm cubed, and the volume is the 19.5, which we will convert into cubic decimeters, and we'll get this same value here. So knowing this is the volume that reacted with the volume of the acid. So we can write an equation to show such reaction, and that gives us sodium hydroxide plus HCl, giving us the salt and the water. We use our mole ratio to find the corresponding moles of the acid. The mole ratio here is 1:1. In other words, for every 1 mole of sodium hydroxide, we will have 1 mole of the acid reacting. So 1:1. That's the agreement between them. If that's the case, then that 0.00195 moles of the sodium hydroxide will as well have the same number of moles of the HCl reacting with it. So the number of moles of HCl in that volume of the HCl used is 0.00195. We used, or in the titration, we used 25 cubic centimeters of the HCl. So that moles that we found was in the 25 cubic centimeters, because it was that volume of the acid that reacted with the base. And we have to move this one, we have to change this one, this volume and this moles into 1000 cm cube or 1 dm to get the concentration. There are multiple ways of approaching, but here once again we go by the first principle, that if 25 is equal to 0.00195, then 1000 is equal to what? So we are going to get 1000 times the moles over the volume of the acid used, and that gives us 0.078 mole per dm cube of the acid. So this is the excess concentration when the calcium oxide reacted with or was dissolved in the acid. That concentration of the acid that was started with, this is the leftover. Yeah, so that is the excess. So knowing the leftover, we can go and subtract it from what we started with to know the concentration of the acid that was consumed or that reacted with the calcium oxide. Here once again, we can still use a relation C is equal to N over V. We know the N here, we know the V here. We just have to convert this one into dm cubed, and it gives us the same answer. So let's proceed. So this concentration here is the concentration consumed. We have to convert this one into moles. That was the question, was to find the moles. So we have this concentration, and we have a volume of 500 cubic centimeters. That was the volume of the acid. So using the relation C is equal to N over V, and for that matter N is equal to C times V, we know the concentration that was consumed, which is 0.0022, and then the volume, which is 500 cubic centimeters, and we convert it to decimeters. That gives us this. It is because we are finding moles, and our unit should be mole. Converting this one into the decimeters cubed, this decimeter cubed here can cancel this per decimeter cubed here, so that we'll be left with a mole. So this is the moles of the acid that reacted with the calcium oxide. The next is a question on the calcium oxide, and we are going to need the molar mass of calcium oxide. So we use the relative atomic masses. Calcium is 40 plus that of the oxygen, which is 16, and that gives us 56 grams per mole. There was a reaction between the calcium oxide and the ACl. So we need an equation to find the corresponding moles of the calcium oxide. And according to this equation, for every 1 mole of the calcium oxide, we need 2 moles of the hydrochloric acid. Or let's read it from this side to that side. For every 2 moles of hydrochloric acid, we have 1 mole of calcium oxide reacting with it, which means that the moles of the calcium oxide is half that of the HCl, because half of 2 is 1. What it means is that with the moles of the HCl that we found, that was the 0.011, half of it will be the moles of the calcium oxide that reacted with it. So we have 0.0055 moles of the calcium oxide. So now that we know this moles, we can proceed find the mass. So we know that amount N is equal to mass over molar mass. With that, we can make mass the subject, and that gives us moles times molar mass. We have used mole ratio to find the moles of the calcium oxide. That is the 0.0055. We have found the molar mass of the calcium oxide. So when we do this calculation, we have 0.308 grams of the calcium oxide. Now we are to find the percentage mass, but knowing this, and we know that a total of 1.5 grams was weighed in the question is there. So what it means is that for that 1.5 grams that was weighed, 0.308 of it was calcium oxide. So if we want to find the percentage mass, we just have to divide that mass of the calcium oxide present by the total mass that was weighed and multiply by 100. That gives us 20.5 grams. So what it means is that about 79.5 grams was just other substances that was in the rock, or was the rock, and out of it 20.5% was the calcium oxide. So now that we know that, and we have been able to go through that, and me here hoping you have well enjoyed it, we end the session with this self-assessment question. I urge you to try your hands on it. So we end the session, and we hope to meet again in the next session.